Welcome to 6WIN's vRouter 2.0 webinar, announcing general availability for our new CLI and NETCONF Yang-based management. My name is Kelly LeBlanc, and I will be the moderator for today's webinar. Presenting today is Jan Rappaport, 6WIN's VP of Product Management. You can ask your questions using the Q&A button at the bottom of the page. We will answer the questions at the end of the webinar in the order that they are received. Let's get started. I will now turn it over to Jan.
Thank you, Kelly. Welcome to this new webinar where I will give you an overview of our brand new management engine and CLI based on NETCONF and Yang. We at 6WIN have decided to completely revamp the management of our vRouters to provide our customers with the programmable APIs to easily integrate with third-party orchestrators, monitoring systems, and management tools. Before I deep dive into this, let's say a few words about 6WIN. 6WIN is a software company headquartered in France with offices around the world, including Santa Clara, California, and Beijing. We make high-performance networking software with deep expertise in telecom. Our flagship product is vRouter software that has been deployed globally for over a decade. And for those of you from the developers community, you may know us as the founders of dpdk.org and a top contributor. In recognition of our innovation, we received an investment from Cisco and multiple awards, including NFV and VNF Products of the Year for our vRouter. This year, we won a vRouter Innovators Award from IDC and SDN Deployment of the Year for our vRouter within our service provider customer Eolo's network. In this case, Eolo replaced hardware routers with SDN routers. We will talk more about this use case in a few minutes. Our vRouters are available in 3 different software packages for white box networking. The first is our 6WIN Gate software, which is source code for Linux networking. 6WIN Gate includes complete and modular layer 2 to 4 networking stacks. Here we help our OEM customers build their own vRouter technology and more, including a full range of additional networking equipment and solutions. The second are software appliances called Turbo Router and Turbo IPsec. These vRouters are ready-to-run appliances for customers who build and operate networks. And the third is virtual infrastructure software for hypervisor networking. These vRouters boost virtual networking and switching performance inside NFV platforms, such as Nuage Networks AVRS and Contron's SIM-Cloud. Our software runs on market-leading processors that leverage DPDK for performance, including x86 and ARM. We've been solving networking performance challenges for our network builder and OEM customers who are using our vRouter technology for over a decade now. Our customer list is impressive with a large global reach, including servicing over 90% of 4G networks in Japan, the top service providers in the US and EMEA, and more. These customers use our software with standard tools such as Linux on commodity hardware to solve some of the largest networking challenges in the industry. Let's review the Eolo use case, which highlights pretty well the way our vRouter can work with a third-party management. Eolo is an Italian service provider that we've been working with for 5 years. Eolo needed to provide fixed wireless broadband to its customers in rural Italy. Rather than buying traditional hardware routers, Eolo decided it build its own custom SDN router using code servers, Linux, and 6WIN Gate vRouter source code for performance. It started the project with 6WIN on Tylera servers, and then migrated to the new Intel Xeon Scalable processors on Advantech Whiteboard Sky servers with the same 6WIN software. As a result, Eolo is now servicing 300,000 customers with a completely flexible SDN router platform that enables a 60% capex reduction compared to legacy hardware equipment such as Cisco hardware routers. As it is software-based, Eolo can customize its SDN routers to evolve for future requirements. To explain why we have decided to rework our management, let's have a look at what's happening in the industry. As standard servers with high-performance networking software now provide the same level of features and performance for a fraction of the price, we progressively see vRouters replace hardware routers. Both service providers and enterprise customers leverage their existing infrastructure to host numerous and complex network functions and decrease CapEx by sharing hardware resources. Automation helps decrease OpEx by achieving network maintenance tasks more efficiently. In other words, the IT and networking worlds converge. Centralized management interfaces coming from the data center world are now used to deploy and manage networking applications such as SD-WAN, VCP, VEPC, etc. This is what we call the next-gen management frameworks. Next-gen management frameworks provide the following features: deployment, installation of software appliances on physical servers or cloud environment with inventory management, license management and enforcement, license key management with usage control, contacted by appliances at startup to check their entitlement, monitoring and analytics, that's recording and monitoring of statistics, alerts, and faults. It gives a graphical view of the overall status of the system. Configuration, intent-based networking configuration of the devices based on standard APIs and protocols, CLI and NETCONF. And lifecycle management, start, stop, restart, update, scale, and heal of network functions. The next-gen management framework itself is very likely to be integrated with other frameworks, from legacy NMS to state-of-the-art cloud management systems by way of NFVO, VNFM, and VIMs. Therefore, it has to expose its capabilities for deployment, license management, monitoring, and lifecycle management through APIs, likely REST-based. And to program the vRouters, the next-gen management framework relies on automation tools such as Ansible and leverages APIs, usually NetConf. At 6WIN, we are making our vRouter ready for such integration. In the next slides, I will focus on the configuration capabilities of the vRouters through a couple of examples, and I will conclude with a short IPsec demo involving CLI and NETCONF management. Let's start with the CLI. Although next-gen management frameworks rely on the NETCONF API, users need the CLI to fine-tune and troubleshoot. Plus, our CLI is based on our Yang models and acts as a NETCONF client for our management engine, so it is a good introduction to our management system. As you can see, question mark or the help command can be typed to get help for all available commands at that path in the CLI. These help messages come directly from the Yang model. Completion is provided by hitting Tab. Let's edit the running configuration, that is, prepare a staging configuration that we will commit as the current one. After typing edit running, we see the prompt changes. We entered edit mode. Let's now configure some IP addresses and host name. Networking configuration happens in a VRF context. Let's enter the main VRF context using an absolute path. We see the prompt is updated. We create an interface. The exclamation mark indicates that the Yang schema is incomplete. This is because an interface definition requires an associated network port. Let's list the network ports available in the system. The show state commands are available from configuration edit mode. We use a command with an absolute path to dump the list of network ports in the system with their corresponding PCI IDs. After binding a port to the new interface, the exclamation mark disappears. We now configure a static IP address. And we go back to the root of the VRF using 2 dots twice to go 2 levels up. Let's do a similar configuration on another interface named DP1, but this time we use one-liners to configure the port and enable DHCP without navigating into the interface context. And finally, let's configure a host name using an absolute path. Show config is used to review the relative configuration. And we can also use an absolute path to review another section of the configuration. After committing the configuration, we can review the state of the router from the configuration edit mode. First, hostname using an absolute path. Then interface DP1 using a relative path from the main VRF context. Let's summarize the CLI features we have just reviewed. The CLI provides standard features like contextual help, completion, and history. It allows to manage configuration files, including start, running, and inactive configurations that can be imported and exported. Browsing is convenient. Users navigate through configuration contexts as they would browse a file system. Relative and absolute path can be used, which is very intuitive. System state can be retrieved from anywhere so that the user can easily compare and copy-paste state information while editing the configuration. Finally, the CLI is actually a NETCONF client that communicates with the vRouter's Yang-based configuration engine. Its command names and statements follow the syntax and the hierarchical organization of the vRouter Yang models. Data consistency is checked against the Yang model so that syntax errors are detected early. This is actually a smooth transition to our next topic. Let's talk about NETCONF and Yang. NETCONF is a network management protocol standardized by the IETF. It defines mechanisms to install, manipulate, and delete the configuration of network devices. It uses XML-based data encoding for the configuration data, as well as the protocol messages. More information is available in RFC 6241. Yang is a language used to model data for the NETCONF protocol. The Yang module defines a hierarchy of data that can be used for NETCONF-based operations, including configuration, state data, remote procedure calls, and notifications for network management protocols. More information is available in RFC 7950. Here is an example of a NETCONF XML configuration. We recognize the items we have previously configured through the CLI. Hostname, DP0 interface with static IP address, and DP1 interface with DHCP configuration. And this is an example of NETCONF XML schema for state, where we recognize the information that was configured previously, such as the DP0 or DP1 interfaces with ports, but also dynamic information, such as the interface counters, or the IP address obtained dynamically through DHCP with the lease information. Finally, let's have a quick look at the architecture of our vRouter 2.0 management, especially in terms of extensibility for our source code users that will add their own data plane or control plane protocols or extend existing protocols with new or proprietary parameters. On top of the Linux and FastPath subsystem, the management engine relies on the Yang data store based on the sysrepo open source project. We have implemented sysrepo services to configure Linux networking for the different features supported in the vRouter in a Python plugin called YAMS for Yang-based management system. YAMS leverages the standard Linux interfaces to configure networking. Then, on top of sysrepo and YAMS, we provide a NETCONF server based on the net2peer open source project. It interacts with sysrepo using the Google Protocol Buffers API and exposes a NETCONF API to the user interface. This API is used by our vRouter CLI that is automatically generated from the Yang models, and also it is available for vRouter users for integration with their own management system. To summarize what we have just seen, we make our vRouters ready for integration with next-gen management frameworks by providing APIs. These APIs are NETCONF Yang-based. Still, we provide a CLI as it is required for fine-tuning and troubleshooting purposes. And for our source code users that extend the vRouter with their own protocols or add parameters to existing services, our management system is extensible. It relies on standards, leverages open source projects and well-known languages, and the CLI is automatically generated when extending the Yang model, as well as the documentation, by the way. Let's now switch to a simple demo illustrating these topics. This demo consists in a simple site-to-site VPN interconnect use case. We will generate traffic from a host on the first site through a security gateway named GW1. The traffic will be encrypted using IPsec and sent to the security gateway of the second site named GW2 to be decrypted and reach the destination host. It is a very simple use case that will allow us to demonstrate the use of our CLI to configure GW1 and NETCONF to configure GW2. It involves IP and IPsec and IKE, of course, but also VLANs and loopback interfaces. Let's dive into the demo. Here is the control center of our demo platform. The two windows in the bottom are consoles on the two security gateways, GW1 and GW2, where we can see the CLI prompt with the host name. The two top left windows are the Linux command lines of the hosts that we will use to generate traffic. And the top right window is the Linux command line of the management host that will be used to perform NETCONF operations. Let's start the demo. On GW1, we can review the help system. Help can be called to see all the commands available in the system. Help show displays the syntax and help for the different available show commands. Show, followed by tab, displays the next available keywords. And show, followed by question mark, displays the keywords with the corresponding help. Let's dump the running configuration using the showconfig running command to check it is empty. Now, let's configure GW1 using the CLI. We enter edit mode, and we load the IPsec configuration that was prepared in advance using the load file command. Let's now navigate to the VLAN 6 interface in the main VRF and display the contents of the configuration we intend to apply. We can also display the information without the default values. We see that VLAN 6 will be configured on top of the NTFP1 interface and will be assigned the VLAN ID 6 and the IP address 10.6.0.1. Using show state, we can check that there is currently no data in the system for this VLAN 6 interface. Let's now review the intended configuration for the loopback interfaces. We can do this without leaving the VLAN 6 context by using an absolute path in the showconfig command. We see that the 172.30.0.1 address will be assigned to a loopback interface named IPsec endpoint. Next, let's navigate to the IKE context in the main VRF using an absolute path. Using the showconfig nodefault command, we see the list of configuration items that we intend to apply, including the pre-shared keys, the IKE and IPsec policy templates that will be used by our VPN, and the VPN itself, with the security policies matching the clear traffic and the encapsulating addresses. we commit the configuration. Let's use the show state command with an absolute path to check that the VLAN 6 interface has been configured in the system. Note that we can do that without leaving the edit mode, so that if we need to adjust our configuration, we don't have to navigate between operational and edit modes to alternatively review the system state and modify the configuration. The VLAN 6 interface is properly configured with the expected IP address and VLAN ID on top of the NTFP1 interface. In the show state output, in addition to the static configuration that we have applied, we can see the interface counters information displaying incoming and outgoing bytes, unicast packets, discarded packets, and error packets. Let's now switch to GW2 configuration. We will apply a similar symmetric configuration, this time using NETCONF. In the management console, let's review the NETCONF schema used to retrieve the VLAN configuration, equivalent to the showconfig CLI command. This is a simple XML file that we will use with our NetConf client to send a getConfig request over the network to the NetConf server running on GW2. We see the result in JSON format, showing that there is currently no information configured for VLAN interfaces. Let's configure VLAN 106 using NetConf. Here is the XML data that configures the interface with the 10.106.0.2 IP address, VLAN ID 106, on top of the NTFP2 interface. We send this data as an edit config request to the NetConf server running on GW2. Then, we send the GET request again to review the configuration, and this time we see the information is properly configured into the system. Now let's do the same for the rest of the configuration. We review the XML data, showing the configuration of the interfaces, ports, IP addresses, IPsec and IKE templates and VPN, which are symmetric to the ones we reviewed previously on GW1. And finally, routing information. We apply this configuration, and we are now ready to process and encrypt traffic. While traffic is running, we will dump it in several places in the system to check clear and encrypted packets. On host 1, let's prepare the ping command that will generate the clear flow towards host 2. On host 2, let's dump the ICMP traffic. We expect to see clear text ICMP echo reply messages. On GW2, let's prepare to dump traffic on the interface connected to GW1, that is at the end of the VPN. We expect traffic to be encrypted. We do that from the CLI using the showTraffic command. We will limit the output of this command to 20 frames for the purpose of readability. And we do the same on GW1 on the interface entering the gateway from host 1. Traffic should be clear text. Let's start the traffic dumps on GW2 and GW1 and initiate the ping from host 1. As expected, we see the ping goes through, enters GW1 in clear, is encrypted between GW1 and GW2, and received in clear on host 2. And this concludes our demo. Now, back to Kelly for the Q&A session.
Thank you, Jan. So this is your chance to ask your questions. And as a reminder, you can ask your questions using the Q&A button at the bottom of the page. So let's start with the ones that we've received. So Jan, the first question we have is, what's the advantage of using NETCONF instead of CLI?
Yes, so there are many advantages for using NETCONF instead of CLI. So first, NETCONF is complementary of CLI. You still need a CLI for fine-tuning, troubleshooting purposes. But everything we do through the CLI in our vRouter is accessible through NETCONF. It's an API. It's a standard. It's model-based. So the integrity of the data you receive and send is guaranteed by the model. It's programmatic for integration with orchestrators and management systems. And finally, NETCONF configuration is faster than CLI configuration.
Okay, the second question here, have you integrated your vRouter with any management frameworks?
Yes, so remember our technology has been used and deployed by major tier 1 customers all over the world for the last decade. And so through this experience, there have been many integrations. So from, I would say, legacy interfaces like Nagios, for example, cloud-based management system, VMware, OpenStack, Cloudify. Of course, our own customers' management framework. We also have customers who have integrated our vRouters with OpenDaylight. And remember, our technology is used by Nuage and Contron in their commercial products. So there are actually many examples of integration of our vRouter with open source, proprietary, commercial, many kinds of management and orchestration frameworks.
Okay, great. We still have about 3 minutes left for questions, so I'll keep going. The next question we have, is Grafana available to use for monitoring today?
Yes, so apart from, I would say, granular monitoring using the CLI or NETCONF to retrieve statistics punctually from the system, apart from legacy monitoring using syslog, using sflow, so very standard monitoring functions, we also provide advanced monitoring and analytics using time series database. Our vRouter can export KPIs to a time series database, and then the user can interface this time series database with the front end to display monitoring and analytics from the system, typically Grafana. So actually, we have done a pre-integration of our vRouter with InfluxDB as a time series database and Grafana as the front end for analytics. This is available on GitHub. It is public. It is an example of integration. Our customers can either start from this integration to do their own product, or they can integrate it with others based on our product as an example. We publish our dashboards for Grafana, so our customers have an example to start from.
Okay, thank you. We have time for one more question, so here it is. Are there any differences for management between bare metal and VM deployments?
Actually, no, we support both bare metal and VM deployments. For bare metal, we support ISO installation, USB installation, Pixie. And for VMs, we support prepackaged images as OVA or QCO2, depending on your hypervisor.
Okay, thank you, Jan. So that concludes our Q&A portion of this webinar. So thank you all for joining our webinar today. If you would like to test drive our new vRouter 2.0 or would like additional information, please visit our website at 6win.com. Our webinar is now closed, and we look forward to hearing from you soon. Bye now.